Okay, question number 1. A girl rides a bicycle that is powered by an electric motor. Okay, it's an electric bicycle. The battery transfers energy to the electric motor. So there's a battery connected to it. The EMF of the battery is 16 volt. Okay, that is given to you, and it can deliver a charge of 43 kilograms. Q is given. When discharging, we complete the full charge. Okay, the maximum speed of a girl on a horizontal load is 7 meter per second. This is a V max. Okay, and the energy from the battery alone, the maximum distance that the girl can travel under this condition is 20 kilometers. Show the time taken for the battery to discharge about 3 into 10 cube seconds. So what we do is we just consider P is equal to S by T. Okay, many of you would have thought, how can you take this one unless the vehicle is traveling with uniform velocity? Now you see, when you are connected a battery to an electric cycle, then the moment you put it into full throttle, then definitely the maximum velocity is the only velocity which the cycle can travel with. Okay, it cannot travel lesser than that, because when we go for full throttle, that's what we assume here. Okay, so the as a result of this, now we have the distance is equal to 20 kilometers, which is 20 into 10 cube divided by time taken, which we do not know, and this velocity v is nothing but 7 meter per second. So I'll substitute all this and get the value of t, which is equal to 20 into 10 cube divided by 7. When I do this, calculate what is this value. Should be, do this calculator, make the screen. 20 divided by 7 would be 2.857. 2.857 into 10 cube, which is nearly equal to v into 10 cube seconds. Next, deduce that the average power output of the battery is about 240 watts. Average power output. What is your power given by? Power is given by force into velocity. You can use like this, or you can also use something like work done divided by time taken. Now let us see what can be used here. See, always in IB problems, one thing that we should be clear about is that when we get some value over here, okay, it will be a continuation of this one. This will be used as an input over here. Now here the time is given over here. Maybe I can use the time here, but I need to get the value of work done. How do I get the value of work done? Let us look at this. What is being given here? The distance is given, then C is EMF is given, and then charge is given. Okay. Now work done can also be calculated by two methods. One is work done is equal to force into displacement. We can do it like this. Okay, if it's a mechanical problem, and if it's an electrical problem, you can also use this as Q times delta V. You remember this one, right? So what is this Q? Q is nothing but the total charge stored in the battery, so which should now be equal to what is given here. Value of Q was given 43 kilocoulombs, and delta V is potential difference of the battery, which is 16 volts. Let us substitute these values, which you get this as a 43 kilocoulombs multiplied by 16 volt, which should now be equal to, let us calculate this also, be 43 multiplied by 16, which will be 688. 688 into 10 cube. Now let me substitute this over here. So this will give me power is equal to 688 into 10 cube divided by time taken is 3 into 10 cube. 3 into 10 cube. When I do this 10 cube goes away. So I get 688 divided by 3 would be 229.3. 229.3 watts over here, which is nearly 230 watt, but here it's about 240 watt. Okay, but it's very closer to this one. Maybe if I substitute this value instead of taking this 3 here, let me do that also, and then show you what will exactly happen. 688 divided by 2.857. When I do this, I get this 240.81. Okay, so you remember you're going to use this value or not this value here, because this is an approximation of this. So when I do this value here, I get 2.857 into 10 cube. When I do this, so I get this value closer to 230 watts. Okay, now let us move on to the next one. Friction and air resistance act on the bicycle. The girl when they move, assume that all the energy is transferred from the battery to the electric motor. Determine the total average force that acts on the bicycle and the girl. Okay, total average resistive force. What are the average resistance force? It says friction and air resistance. Both is nothing but the contributing to the average resistive force. So what we do is we consider frictional force, total average resistive force, multiplied by the velocity should now be equal to the power that the this one is getting dissipated. So as a result of it, this FF should now be equal to P by V, which should now be 240 divided by 7 over here. And as a result of this, now what I can do is, now wait, this is not 240, 240 is nothing but the power delivered by it, but now you see here, the total work done by the battery is not equal to the power. So here it is, wait just a minute, let me show you the thing here. This should be frictional force Okay, part 3. So friction and air resistance acts on the bicycle and the girl when they move up. When they move, assume that all the energy is transferred from the battery to the electric motor. All the energy is transferred from the battery to the electric motor. How much energy is getting transferred? If you want to know this, the energy transferred is nothing but the energy contained in the battery. What was the energy contained in the battery? Which is nothing but the work done by it, which should now be equal to Q times delta V, the energy stored in the battery, which should now be equal to, what was the Q times delta V? We calculated somewhere here, right? Which is nothing but 688 into 10 cube. See, this is wattage. We don't need this one here. We need this one, 688 into 10 cube. So let us take this value directly from here, 688 into 10 cube. And then it starts with the electric motor. Determine the average resistive force. You need to find out the average resistive force. So this much amount of energy was used in the average resistive force, okay, to overcome the resistive force. So therefore, and because of overcoming the resistive force, the distance traveled by the cycle was seen to be d over here, which was seen to be 20 kilometers. See this problem here already given. Okay, so when this amount of energy is being given by the battery, being given here, the maximum distance the girl can travel under these conditions. What do you mean by these conditions? That means the conditions at which the cycle runs only on the battery seem to be 20 kilometers. Okay, so therefore this is 20 kilometers over here. Let me substitute this value. So this should be 688 into 10 cube should now be equal to frictional force multiplied by 20 into 10 cube. This 10 cube goes away. Frictional force or resistive force would be 688 divided by 20, which should now be equal to, there is a 688 divided by 20, which is 34 point. So get this as 30.4 Newton. 34.4 Newton. Okay. Let me move on to the next question. The bicycle and the girl have a total mass of 66 kg. Okay, 66 kg. The girl rides up a slope that's at an angle of 3 degrees to the horizontal. This angle is given to you. Calculate the component of the weight of the bicycle and the girl acting down the slope. What component of weight acts down the slope? Acts down this component here. So as you know from free body diagram, if W is the weight acting like this over here, okay, which you call it as the mg, and write this as the mg itself because we are all used to this mg over here. And this is my normal force. How does normal force act? Normal force actually acts here. I'll write the normal force here. I'll write the normal force over here. This is my normal force. So the component of W along this direction would be equal to mg. This is a theta, right? If this angle is theta, this angle is theta. mg cos 30, and along this direction should be mg sin theta. It's a straightforward problem. We have already done so many problems in mechanics. I think this would be easier for you. So therefore, what's the value of mg? This is m is 66 over here. 66 over here. This should be 66 times g times sine 3 degrees over here. Let us calculate what is this value you get. So to get the correct answer, 66 multiplied by 9.8 multiplied by sine of 3 degrees. So I think sine of 3 degrees. What I will do is I'll just cancel this initially. Cancel this. I'll just write 3 here. Find 3. Go to trigonometry. find the sign of value of t here, degrees. Now multiply, come out of this, multiply this by 66, multiply this by 9.8, get the answer 33.85. 33.85. See here it is two significant figures over here. So I will make this as 34. From what is the unit? Newton. Answer is 34. Okay. Next. The battery continues to give an output power of 240 watt. Assume that the resistive forces are the same as in A3. Calculate the maximum speed of the cycle and the curl on the slope. See, when it was something like a straight line, then definitely the maximum speed of the bicycle was seen to be how much? Which we already seen here. How much was it? It was seen to be around 7 meters per second. Okay. Now, instead of having something like a straight slide, okay, you have something like a slope. When you have a slope, what will happen? The maximum speed should now decrease, right? So we need to find out that value. It will not be 7 meters per second. It will be lesser than 7 meters. Let us calculate that also. So towards it. So why do we get lesser value? Because now there are two components acting. One is when you have a slope here, then the first component that was acting here earlier was seen to be the frictional force. What was the frictional force acting here? Frictional force was seen to be 34.4 newtons, right? So this was seen to be 34.4 newtons. This was seen to be here on the ground. It was 34.4 newtons, and on the component of weight, this was 34 newtons. This is 34 newtons. 34. So yeah. So therefore, the total force that acts here is not 34.4 newtons, but it is 68.4 newtons. Okay. So total force is 68.4 newtons. Now what is that we need to find? We need to find out the maximum speed. How do we find? We know that the power delivered is always the same. It doesn't change, right? Which should now be equal to F into V. Once again, this should be 240 should be equal to 68.4 multiplied by velocity. In fact, we don't even need to calculate this. You see, when it was 34 Newton, it was 7 meter per second. When it is 68 Newton, it automatically becomes 5 meter per second. Sorry, 3.5 meter per second. Okay. Let us do this if you want the calculation. So we should be 240 divided by 68.4. When I do this, what do I get here? 240 divided by 68.4 should be 3.5. I told you, right? So this is 3.5 meter per second. So this is the maximum speed which the cyclist can attain when she is going on to a slope of 3 degrees. Now you can also think about, okay, if suppose if the slope was not 3 degrees, it was 6 degrees, 10 degrees, 20 degrees, and so on, how will the speed actually reduce? Speed will start decreasing again, right? Let me move on to the next one. On another journey up the slope, the girl carries an additional mass. Explain whether carrying this mass will change the maximum distance that the bicycle can travel along the slope. So what is it doing? She is now carrying an additional mass. Okay, how does she carry? When she carries an additional mass without calculation, so what you have to do is you need to find out this. So what can happen? So when you have a slope like this, there was one force due to the weight, which was nothing but W sine theta. Here. The other one due to friction over. The friction is not going to change over here because it depends upon the, well, friction also gets changed, okay, because friction is nothing but mu times n, which would be mu times mg sine mg cos theta. So therefore what will happen? The total energy which has been taken over by the resistive forces along with the weight will now be equal to mu times mg into sine theta plus cos theta. That is what we get over, right? But not mu times mg into sine theta plus mu times cos theta. That's what you get over here. So as a result of it, you see, this depends on mg over here. When you add more weight to this, now what can happen? This will become mg plus m dash g will get, right? Into sine theta plus mu times cos theta will get. As a result of it, what will happen? The total force, each total force F will now increase. When total force F is increasing, and you are delivering the same power, okay, then what will happen? F into D once again, if I use this, like what you had done in the previous formula, so this value of D is equal to P by F over here. When F is increasing, what can happen to D? D will automatically start reducing, right? D starts reducing, and therefore the maximum distance traveled by the bike would be less. Let's say maximum distance traveled will become less. Will become less. And you have to mention this, okay, whatever is the reasons that you have got. Yes. Okay, let me move on to the next. The bicycle has a meter that displays the current and terminal potential difference PD of the meter, battery, and the motor is running. Okay, so PD is given, current is given, and the diagram shows the meter readings at one instant. The EMF of the battery is 16 volts. So this is your V, this is your terminal potential difference V, and this is your current I. So how are these related? Determine the internal resistance of the battery. You need to find out this. These are related using the equation E equal to V plus I into R, right? So therefore, now we have, I want to get the value of E is 16, V is 12, plus I is 6.5 times R over here. So let us calculate the value of R. So this is 6.5 times R is equal to 16 minus 12, which is 4 over here. This implies R is equal to 4 divided by 6.5. When I do this, calculate what the answer I get. 4 divided by 6.5. It is 0.615, which is nearly 0.62 unit is ohms. 0.62. Let us move on to the next one. Okay, part E. The battery is made from an arrangement of 10 identical cells as shown. Calculate the EMF of one cell. So what we need to do? So let us calculate. Let us say this is E, this is R, this is E, comma R. So if I have 5 cells like this, the EMFs can be added in series. So therefore, I get one branch of all the EMFs added, which should be having 5 times E, and the internal resistors are also in series, so they should be having 5 times R, right? And similarly, here also I have 5 times E, comma 5 times R. Okay, I have this circuit. Whole circuit gets modified like this over here. Now, as a result of it, now whenever I have two batteries like this, there is a formula which connects this like so here. Let us say this is E1, this is E2, this is R1, this is R2. Then we can write E total divided by R total is equal to E1 by R1 plus E2 divided by R2. You see, this equation is not there in your data booklet. I'm telling you very clearly, it's not there. But anyway, it's so easier to understand over here. It's nothing but I total. See, this is your I total. E total by R total is nothing but I total is equal to E1 by R1, the current that comes from here, the current that comes from here, KCL, nothing else. Okay. So therefore, E1 by R1 plus E2 by R2, I can do it. Now, what we have here, E1 is nothing but 5E by R1, 5R, should be equal to E by R over here. And here also it is E by R over here. So therefore, I can now write this as 2 times E divided by R over here, right? And thus, now what I can do, E total, right? E total is equal to 2E divided by R into R total. What is R total? R total is nothing but, see here what do we have? Here we have 5R in this branch, and here we have 5R in this branch. So the effective resistance would be 1 by R total would be equal to 1 by 5R plus 1 by 5R, which would be equal to 2 by 5R, or R total should be equal to 5R divided by 2, which should be 2.5 times R. Okay, so I will write this as a 2E by R into 2.5 times R. This R and R goes away. 2 into 2.5 is nothing but 5 times E. 5 times E. So thus, what is E given? The entire set of these cells is equal to 16 volt. It is already known to you. So the value of E would be 16 divided by 5. What is the value of 16 by 5? Do this, 16 divided by 5 would be 3.2 volt. So the answer is 3.2 volt. Okay. Now let us move on to the next one. The internal resistance of one cell. We already calculated this one here. So the internal resistance of the full battery is seen to be 0.62 volt. So internal resistance of the total internal resistance is equal to 0.62 ohms. This is already known to you. Now what is happening over here? The internal resistance of the first branch is seen to be 5R. The second branch is 5R, and then we calculated the whole thing and we got this equal to 2.5 times R, right? The entire combination of this full series is seen to be 2.5 times R, where R is the internal resistance of each cell. So therefore, I write this as 2.5 times R is equal to 0.62. So R cell should now be equal to 0.62 divided by 2.5. So don't get confused with this R and the R that we calculated earlier. This R is nothing but the internal resistance of the each cell. Okay, because there are 10 cells we have arranged parallel and series configuration. And that the small R that we defined there is nothing but the internal resistance of the full battery. That's what we have written over here. So when I do this and calculate what is this value, what do I get here? I get 0.62 divided by 2.5 comes out to be 0.0248, which is nearly 0.25 ohms. Thus the internal resistance of each cell is equal to 0.25 ohms. Okay. Now let's move on. Okay, I think we have come to an end to this question. So tomorrow we will continue with the next. Thank you.